Dear learners, a very warm welcome in the MOOCs of Emerging Technologies in Energy Sources. In this week and in this particular module, we are going to discuss about ocean thermal energy. I am Dr. Shweta Tripathi, Assistant Professor in Mechanical Engineering from School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. The learning outcomes of this module is to understand the ocean thermal energy and to describe the working principle of ocean thermal energy conversion, to classify various types of ocean thermal energy conversion system, to discuss the relative advantages and disadvantages of ocean thermal energy conversion system and the knowledge of the applications of ocean thermal energy conversion. The oceans cover a little more than 70% of the Earth's surface, and this makes them the world's largest solar energy collector and energy storage system. On an average day, about 60 million square kilometers of tropical seas absorb an amount of solar radiation equal in heat content to about 250 billion barrels of oil. Various parties estimate the amount of energy that can be practically harvested to be in the order of 3 to 5 terawatts without affecting the temperature of the ocean or the world's environment. That's about twice the global electricity demand that is nowadays. The oceans are thus a vast renewable energy resource. The technology is viable primarily in equatorial areas where the year-round temperature differential is at least 20 degrees Celsius. If we see in this picture, you can see the areas which are suitable for ocean thermal energy conversion. Apart from producing electricity, ocean thermal energy also offers the possibility of co-generating other products like efficient seawater air conditioning, SWAC, fresh water and nutrients for enhanced fish farming and algae production. You have already learned that this algae is nowadays a very promising source of biofuel. Ocean thermal energy conversion. It is a method for generating electricity which uses the temperature difference that exists between deep and shallow waters. Actually, this ocean thermal energy conversion produces electricity from the natural thermal gradient that is available in the ocean. We are actually using the heat that is stored in warm surface water to create a steam to drive a turbine, while pumping cold, deep water to the surface to recondense the steam. And the temperature difference between warm surface water and this cold deep water should be greater than 20 degrees centigrade for any ocean thermal energy conversion system to produce significant amount of power. Why? Because we are generating power from the temperature gradient only. Now, if we look towards the history of this ocean thermal energy, in 1881, a French scientist, Astronoval, was first to propose tapping the thermal energy that was available in the ocean. Then in 1881, George Claude built an experimental open cycle thermal energy conversion system which produced about 22 kilowatt of electricity. Then again in 1956, a French researcher designed a 3 megawatt open cycle OTEC unit, OTEC open thermal energy conversion unit at Africa's west coast. It was too expensive and then they quit the project. Then further in 1979, first 50 kilowatt closed cycle ocean thermal energy conversion demonstration plant went up at Nela, which is known as mini OTC. And then in 1980, US Department of Energy built Ocean Thermal Energy Conversion System, which was named as OTEC-1. Then the Japan in 1981 demonstrated a shore-based 100 kilowatt closed cycle plant, and they used freon as a working fluid, and titanium shell and tube exchanger was used there. Then in 1984, Solar Energy Research Institute developed a vertical evaporator to convert warm seawater into a low pressure steam, and this steam was utilized in open cycle plants. Then further in March 2013, Saga University with various Japanese industries completed the installation of a new ocean thermal energy conversion plant, and Okinawa Prefecture announced the start of the ocean thermal energy conversion operation testing at Hume Island on April 15, 2013. Now if we talk about the Indian scenario for ocean thermal energy conversion systems. So India is geographically well placed as far as the ocean thermal energy conversion potential is concerned. We have around 2,000 kilometers of coast length along the South Indian coast, and the temperature difference is about 20 degrees centigrade throughout the year. So more than 1 lakh square kilometers of tropical water is available in the exclusive economic zone around India, having power density of 0.2 megawatt per kilometer square. Apart from this, attractive ocean thermal energy conversion plant locations are available around Lakshadweep and Andaman and Nicobar Islands. It means India has an opportunity to develop the ocean thermal energy conversion system for India. Considering this, India has signed an MOU in 1997 between NIOT and Saga University, Japan, for a joint development of ocean thermal energy conversion in India. Then NIOT conducted detailed survey at the proposed ocean thermal energy conversion site near Tuticorin, South India. Based on the temperature and bathymetric profiles, the optimization of the closed loop system was done with the help of Saga University in 1998. Now, considering the future need of large plants, it was decided to design a floating ocean thermal energy conversion plant. NIOT aims to build a 1 megawatt floating ocean thermal energy conversion plant off the coast of Tamil Nadu near Tuticorin port on the southeast coast of India, which is free of cyclones in the last 4 decades. Then NIOT planned to shift the same plant to the Andaman and Nicobar Islands for power generation, and this will be a stepping stone for the proposed 10 to 25 megawatt range shore mounted power plants. The experience from 1 megawatt floating ocean thermal energy conversion plant could be scaled up for the construction of 100 megawatt range commercial plants in the nearby future. But with the foreign vendor closing down its operation, it had to be abandoned. Then India's maiden ocean thermal energy conversion project is coming up in the Kavaratti, capital of the Lakshadweep of the southwestern coast after almost 3.5 decades of initial plants. And the plant in Lakshadweep is a land-based since deep water is available close by. So for mainland and offshore platform mounted plant moored in deep wells will be needed. Then why do we need ocean thermal energy conversion system? Because the energy conversion system mostly for the electricity purpose is by fossil fuels, and these fossil fuels in near future will be consumed, so we have to choose for alternative source. India has the option for many alternative energy resources, but to meet the demand we have to go for all the opportunities that are available in the field of alternative energy resources. Then we have to think about all the options that we have or all the alternatives that we have for the energy conversion. So if we see this ocean thermal energy conversion, this has the potential to generate electricity. It is a clean energy source also, and it uses renewable solar collector instead of artificial collector also. So if we talk about the environment, it is also better for this kind of system. It can be used to produce desalined water also. Generally the water in those coastal areas is having salt, so salt free water can be produced. So these are the advantages, or we can say why we need ocean thermal energy conversion plant. Now if we talk about the technology that is available for the ocean thermal energy conversion system, generally the technology that converts the thermal gradient that is available in the ocean to electric power is known as ocean thermal energy conversion. So generally the solar radiations, why there is a thermal gradient? Because of the solar radiation. So this technology converts the solar radiation into electric power. But how? It is absorbed in the water in the ocean is absorbing the solar radiation, and hence a thermal gradient is there, and this thermal gradient is used to convert it into the electrical energy. Ocean thermal energy conversion, here hydro energy conversion system is also used for ocean's natural thermal gradient. So the fact is that the ocean's layers of water have different temperature, similar to run a heat engine. So the layers of water in the oceans have different temperatures to drive a power producing cycle. As long as the temperature between the warm surface water and cold water differs by 20 degrees centigrade. So generally this kind of thermal energy conversion process is based on Rankine cycle. This is a thermodynamic cycle which converts heat into work through a heat engine. So here we use the vertical temperature gradient in the ocean as a heat source or sink. Now the working principle. So the temperature differences generally increases with decreasing latitude. In the tropics, thereby mainly used in equatorial water where temperature difference is greatest. This ocean thermal energy conversion system uses the ocean's warm surface water with a temperature of around 25 degrees centigrade to vaporize a working fluid. And this working fluid is generally ammonia etc., which has a low boiling point. So the vapor expands and spins a turbine coupled to a generator to produce the electricity. And the vapor is then cooled by seawater that has been pumped from the deeper ocean layer where the temperature is about 5 degrees centigrade. So it condenses the working fluid back into a liquid, so it can be reused also. So this is a continuous electricity generation cycle, and the efficiency of this cycle is strongly determined by the temperature differential. The bigger the temperature difference, the higher the efficiency. So the technology is therefore viable primarily in equatorial areas where the year-round temperature differential is at least 20 degrees centigrade. Now the classification. The classification of ocean thermal energy conversion system. So on the basis of cycle, they are classified as closed cycle ocean thermal energy conversion system, open cycle ocean thermal energy conversion system, and hybrid ocean thermal energy conversion system. Now this open and closed cycle ocean thermal energy conversion system can operate either on the shore, that is land based, or out at sea, then floating or grazing. So both have their advantages and limitations, which we will consider just after discussing these systems. Now land based ocean thermal energy conversion plant. So land based ocean thermal energy conversion plants are constructed on the shoreline with 4 large hot and cold pipelines dipping down into the sea. A hot water input, a hot water output, a cold water input and a cold water output. So 4 pipelines are there. So unfortunately, this shoreline construction makes them more susceptible to problems like coastal erosion, damage from hurricanes and other storms, etc. Now sea-based ocean thermal energy conversion plants. They are essentially the same, but they have to be constructed on some sort of tethered floating platform, not unlike a floating oil platform, with the 4 pipes running down into the sea. Early prototypes were running from converted oil tankers and barges, etc. They also need a cable running back to land to send the electrical power they have generated to the shore. Now hybrid forms. Hybrid forms of ocean thermal energy conversion systems are also available, and ocean thermal energy conversion platform is built at some distance, in this case, in the case of hybrid forms, some distance offshore on the continental shelf, which would share some of the advantages of the land-based ocean thermal energy conversion system, and the stability and durability, closeness to the shore and so on. And some advantages of floating ocean thermal energy conversion system is also there. There is an opportunity to exploit a greater temperature gradient, so it may generate more power more efficiently. Now open cycle ocean thermal energy conversion system. In open cycle ocean thermal energy conversion system, the sea water is itself used to generate heat without any kind of intermediate fluid. At the surface of the ocean, hot sea water is turned to steam by reducing its pressure. And just remember that a liquid can be made to change state into a gas either by increasing its temperature or reducing its pressure. So the steam drives a turbine and generates electricity, similar as in closed cycle ocean thermal energy conversion system. Before being condensed back to water using cold water piped up from the ocean depths, one of the very interesting byproduct of this method is that heating and condensing seawater removes its salt and other impurities. So the water that leaves the ocean thermal energy conversion plant is pure and salt free. That means open cycle ocean thermal energy conversion plants can develop as desalination plants, purifying water either for drinking supplies or for irrigating crops. This is a very useful added benefits in hot tropical countries that may be short of fresh water. The sea water is itself used to generate heat without any kind of intermediate fluid. At the surface of the ocean, hot sea water is turned to steam by reducing its pressure. We have already discussed that we can do this. So the steam drives a turbine and generate electricity. This means open cycle ocean thermal energy plant can develop desalination plants, purifying water either by drinking supplies or for irrigating crops. Now closed cycle ocean thermal energy system. In this, the pipe flows through a heat exchanger fixed in the hot surface waters of the ocean, which makes the ammonia boil and vaporize. The heated ammonia vapor expands and blows through a turbine, which extracts some of its energy, driving a generator to produce electricity. Once the ammonia has expanded, it passes through a second heat exchanger where cool water pumped up from the ocean depths condenses back to a liquid so it can be recycled. Here the function of ammonia is same as the function of the coolant in a refrigerator, which is also designed to pick up heat from one place, that is the chiller cabinet, and carry it elsewhere to the outside of room using a closed loop cycle. So in ocean thermal energy conversion, the ammonia picks up heat from the hot surface ocean water, just as the coolant chemical picks up from the chiller compartment, and it carries it to the turbine where much of energy is extracted and is then condensed back to a liquid so it can run round the loop for more heat. Similarly, as the coolant in a refrigerator is compressed and cooled in the fins around the back of the machine. Now the advantages of closed cycle ocean thermal energy conversion system. The size of the plant is lowered in closed cycle compared with open cycle because of high running pressure, that is 9 to 16 bar. The cost of energy generation is reduced in closed cycle, efficiency is higher, corrosion on turbine and other parts is avoided, and as the secondary fluid boils at temperature available in hot water, it doesn't require any kind of vacuum pump, etc. So the fabrication of a steam turbine is easier than a Lasse turbine that was used in open cycle. Now the hybrid cycle, a combined feature of both the closed cycle and open cycle system is available in case of hybrid cycle. In a hybrid ocean thermal energy conversion system, warm seawater enters a vacuum chamber where it is flash evaporated into steam, which is very similar to the open cycle evaporation process. And then the steam vaporizes the working fluid of a closed cycle loop on the other side of an ammonia vaporizer. So the vaporized fuel then drives a turbine that produces electricity, and the steam condenses within the heat exchanger and provides desalinated water. Advantages of hybrid system: it is environmentally friendly, it can provide useful environment in areas bordering on tropical seas, it can produce electricity without giving off any carbon dioxide and do it for a long period. The additional products, that is food, potable water, air conditioning, etc., which can readily be provided. So potable water production alone can reduce electrical generating cost by up to 1/3 and is itself in very considerable demand in most areas where ocean thermal energy conversion can operate. This cold sea water is rich in nutrients and can be utilized for water plants or for aquaculture used to increase the production. So the thermal resource of the ocean ensures that the power source is available day or night and with only modest variation from the summer to the winter. Now the limitations. So despite many advantages, why they are not so popular? So the major limitation or disadvantage of this kind of plant is that the cost is very high. The construction and pipe length affects the marine ecosystem also. And the closed cycle ocean thermal energy conversion can cause the pollution if intermediate chemicals leak into the ocean. The heat exchangers, that are evaporator and condenser, They must be made of highly conductive material, which also will increase their capital cost. And the marine environment gets affected by these plants through water heating also. And the release of toxic chemical and entrapment of a small sea organism in intake pipe is also very common. The thermal layer of sea water near the plants get disturbed because of the discharge of low and high water at intermediate level. The marine life gets affected because of change in pH and dissolved oxygen, etc. Now the applications of ocean thermal energy conversion system. A closed cycle ocean thermal energy conversion plant can also act as chemical treatment plant, and the enclosing area can be used for aquaculture and mariculture also. The deep sea cold water is rich in nutrient and can be used for various applications. Desalinated water, which can be used for irrigation and human consumption. So these are some of the applications of ocean thermal energy conversion system. Now the summary. So in this particular session, we have discussed that the technology that converts the solar radiation into electrical power, ocean thermal energy conversion, hydro energy conversion system, which can use ocean's natural thermal energy gradient to convert into the energy. So basically, the solar energy is trapped in the water of ocean, and this trapped solar energy increases the temperature of the water, and this thermal gradient that is generated due to the hot water and due to the temperature of the water and the shore, a natural thermal gradient is there, and this is used to generate energy. We have learned the fact that ocean's layers of water have different temperatures which are available to run a heat engine. We have discussed that it is based on Rankine cycle. We have discussed that a country like India, which has a long coastline, for this it is a very good alternative source of energy. We have discussed about open cycle systems, and we have learned that this system relies on low pressure environment to actually boil the ocean water and create steam. We learned that when warm ocean water moves into a low pressure environment, it will boil, and the steam is almost pure water as the salts and other impurities are left behind. We have discussed the steam then recirculates and condenses back to water. The warm sea water is flash evaporated in vacuum chamber at an absolute pressure of 2.4 kilopascal. The steam expands over a low pressure turbine and the generator produces the electricity. The average pump work that is required in open cycle plant has to handle very large quantity of warm and cold water because of low water temperature difference. We have discussed about closed cycle ocean thermal energy conversion system also. We have discussed that warm sea water vaporizes. A working fluid such as ammonia is used as a secondary fluid for flowing through a heat exchanger, and the vapor expands at moderate pressure and turns a turbine coupled to a generator that produces electricity. This vapor is then condensed in another heat exchanger using cold sea water pumped from the ocean depths through a cold water pipe, and the condensed working fluid is pumped back to the evaporator to repeat the cycle, and the working fluid remains in closed system and circulates continuously. We have also discussed about the hybrid thermal ocean thermal energy conversion system, and we have seen that this kind of thermal energy conversion plants have the benefit of both open and closed cycle ocean thermal energy conversion plants. So we have discussed about the relative advantages and limitations of the ocean thermal energy conversion plant. Thank you very much.